guys, welcome once more to another video in our YouTube channel. In today's video, we are going to continue with the solving of the Northwest Regional Mock Further Maths Paper 1 2022, and we are going to be solving from question 24 right up to question 34. But before solving those questions, we are going to begin by solving question 12, which was not included in the previous video. So this is part 3 of the video. The previous video was part 2. So if you have not watched part 2, and also there is a part 1 which was the solutions of the first 10 questions, that is question 1 to question 10. Part 2 is just the solutions from question 11 to question 23, excluding question 12 because by then I never had the question 12. And I thank the student very much for sending me the question 12 so that I can include it in part 3. So if you have not watched part 1 and part 2, I'm going to include the links to those videos in the description and in the comment section, so that after watching part 3 you can watch part 1 and part 2 as well. So endeavor to subscribe to the channel, invite your friends so that they can also benefit from our resources. So let's get started. Alright, so we are going to begin with question 12 before moving to the first question under part 3, that is question 24. So question 12 was on applications of integration, and the question reads: an estimate for the integral from 1 to 5 of 2 raised to the power x dx using Simpson's rule with 3 ordinate is. So the term ordinate here should not scare you. Ordinate simply means x. So we are simply finding this integral using Simpson's rule with three values of x. Now the main aim is to know the formula for Simpson's rule, which you can find in your formula booklet, and to know the values of x that you're going to use, the 3 values of x that you're going to use. Now the 3 values of x you're going to use, 2 values of x are the limits of integration. So 1 and 5 are already the 2 values. You are now left to determine the third value. The third value is now the mean between 1 and 5, which is 1 plus 5 divided by 2, that is 3. So we have our table. We have the ordinate values, which is x. 1 and 5 are the ends, 1 and 5, and then now the midpoint between them is 3, gives us the third value. If we're using 5 ordinates, because we cannot use even number of ordinates when you're dealing with Simpson's rule, because if you use an even number of ordinates, then it's not going to be possible, because the step length is going to be not going to be conserved. This is what I'm saying. If maybe we want to use 4 ordinates, then we are going to come between 1 and 3 and we are going to input an ordinate there. It's going to make the step length not to be conserved. We are going to see why. If we are using 5 ordinates, for example, so we always use odd number of ordinates generally. So using odd number of ordinates, so we have 3, 5, 7 and so on. So if we are using 5 ordinates, we are going to come between 1 and 3, we input an ordinate. Then we come between 3 and 5, we input another ordinate. So between 1 and 3, the ordinate that we are going to input is 2, because it is the mean value between 1 and 3. Now between 3 and 5, the ordinate we are going to input is 4, because it is the mean value of 3 and 5. That's 3 plus 5 divided by 2. But we are dwelling ourselves with 3 ordinates, so this case is okay. Now we need to compute the value of this function at those respective ordinates. The function is 2 raised to the power x. When x is 1, we call it x0. y0 is equal to 2, because it's 2 raised to the power 1. When it is 3, we have 8, and when it is 5, we have 32. Now Simpson's rule is telling us that the integral of that function is the step length divided by 3 times the sum of the ends, y0 plus y2, plus 4 times the sum of the odd values of y, then plus 2 times the sum of the even values of y. You can check your formula booklet, you're going to see the formula, or maybe your textbook, or maybe on Google, to understand why I'm saying 4 times odd and 2 times even, because I have not written it here. Alright, so in this case I never put 2 times even, because we have just odd values of y here after the ends, which is y1. The odd is in the sense that the subscript value of y is odd. 1 is odd, so we have 4 times 1, 4 times y1. So from there we just input the respective values. So we have y0 plus y2, 2 plus 32 is 34. Now 4 times 8 is 32. Adding those, you have 66 divided by 3 is 22, and you multiply by 2 gives us 44. So using Simpson's rule with real ordinate, that integral gives us 44. So the answer is C. Now question 24 now, which is the beginning of part 3 of the questions in part 3. It came from the topic matrices, and the question reads: the value of k for which the matrix is not invertible is. So a matrix is said to be invertible if the determinant of the matrix is different from 0. Invertible means it has an inverse. So if it is not invertible, it means that the determinant is equal to 0. So since we are finding the value of k for which the matrix is not invertible, we are just going to take the determinant of the matrix and equate to 0, saying that the matrix has no inverse. So doing that, you can find the determinant of a matrix. You're going to get k to be equal to negative 15. So the correct answer is option A. Now the next question is question 25, reduction formula. The question reads: given that I of n is the integral from 0 to pi ln 2 of cos raised to the power n dx is equal to n minus 1 on n times I of n minus 2. The goal is to obtain the value of I5. So to get I5, we begin. I5 is when I is equal to 5. So I equal to 5 here, we have 5 minus 1 is 4 divided by 5. I of 5 minus 2, 3. So I5 is 4, fit I3. Now we need to compute I3. I equal to 3, we have I3 is equal to 3 minus 1 is 2 divided by 3 times I. 3 minus 2 is 1. So I3 is 2/3 I1. Now we need to look for I1, or from there we can get I5 by fitting 2/3 I1 with I3, and we get 4 fit times 2/3 times I1. Now I1 is simply letting n to be 1 here and looking for the integral from 0 to pi ln 2 of cos x dx. That's when n is 1. So doing that, integrating cos x, you get sin x from 0 to pi ln 2. So I1 is equal to 1. Now we need to find the value of I5. So we just get 8 divided by 15. So the correct answer is C. Now question 26 is on permutations of groups, not really permutations, but group permutation. So basically, let me say algebraic structures. So the question with the inverse of this permutation is, now this is my permutation. I can call it M. It's given by that 1, 2, 3, 2, 3, 1. Those are the entries. Now, since it is a permutation, for me to find the inverse, I need to look for the relationship between the elements that are involved. So it is something like this. When you're given a permutation like this is a relationship. So the arrow points down. So you have something like that. So it means that the element 1 relates with the element 2. The element 2 relates with the element 3, and the element 3 relates with the element 1 because the arrow is pointing down. So the element 1 relates with 2, 2 relates with 3, and the 3 relates with 1. Now we want to find the inverse of this permutation. So we are just going to reverse these arrows. So the element 2 this time around is going to relate with 1, 3 is going to relate with 2, and then 1 is going to relate with 3. So 1 is going to relate with 3, 2 is going to relate with 1 because 1 was relating with 2, and 3 is going to relate with 2. So from there, we keep the first row constant, which is 1, 2, and 3, and then now we reverse, we impute their relations to get the inverse. So 1, 2, 3 is constant, 1 is relating with 3 because 3 was relating with 1. Now 2 is relating with 1 because 1 was relating with 2, and 3 is relating with 2 because 2 was relating with 3. So with that, we get the response as D. Alright, so we are going to proceed with the next question, which is question 27. It came from the topic resistive motion. And the question reads: a particle of unit mass is falling vertically in a medium, which the resistance to motion is kV. V is the speed and k is a positive constant. The equation of motion of a particle is, you have been given the various responses. So let's get the diagram to what is happening. The particle is falling vertically downward in a resistive medium. So the particle is falling like this. Now, this indicates that the particle is moving downward. Now, there's resistance to the motion which opposes the motion of the particle, so the resistance is going to be moving upward. which is kV. Now since the particle is falling, then the weight of the particle is what causes the particle to move downwards, and the weight is mg. So we can now use our Newton's second law of motion, which says that the net force is equal to the mass times the acceleration. In this case, the net force is simply the forward force minus the backward force. The forward force is mg, the backward force is kV. So we have mg minus kV is equal to the mass times the acceleration. Now, in our equation, we're told that the particle has a unit mass. It means the mass is equal to 1 kilogram. So with that, we just replace m with 1, and we get g minus kV to be equal to a. But our responses here are in terms of derivatives. So the acceleration can be expressed in terms of the derivative of the velocity. So acceleration is simply change in the velocity with respect to time. So we get our g minus kV to be equal to dv by dt. So the correct answer is option B. Now question 28 came from the topic functions. The question reads, the domain of f of x equal to the ln of 1 plus 3x divided by 1 minus 3x is. So the domain of a function is simply the set of values of x for which the function is always defined. And in this case, we are defining functions in the set of real numbers, even if you're not told. So we don't define functions in the set of complex numbers in the advanced level. So we define functions in the set of real numbers. So we need to look for the domain of definition of this function. Now to find the domain of definition of a function, we simply find the we identify all the functions involved, we find the domain of definitions of all those functions, and we take the intersection. Probably do it on a number line. You get the domain of definition of the function. Now this is a Napierian logarithm function. It is composed of 4 different functions. You have the linear function 1 plus 3x, you have the linear function 1 minus 3x, and then you have the rational function 1 plus 3x over 1 minus 3x, and then you have the Napierian logarithm function, the ln of that rational function. So the domain of definition of this function will be gotten by the intersection of the domain of definitions of all those functions that were listed. So 1 plus 3x is a linear function, so it's defined for all values of x in the set of real numbers. 1 minus 3x is also a linear function defined for all values of x in the set of real numbers. Now the ratio between the two functions will not be defined for all values of x in the set of real numbers. For the ratio or for a rational function to be defined, the denominator should be different from 0. So for 1 plus 3x on 1 minus 3x to be defined, 1 minus 3x should be different from 0, so x should be different from 1/3. So that's the domain of the rational function. Now for this ln function to be defined, you know that in the set of real numbers, only the ln of positive numbers exist. So for the ln function here to be defined, the interior here should be greater than 0. Now you can factor out the negative sign from the denominator, or we divide both sides of this inequality by the negative sign. You cause the inequality sign to change, and you cause the negative sign here comes to 1 and the positive sign remains at 3x. We can now divide both sides by 1/3. Here you have 1/3, here you're just going to have x. Here you have x, and here you have 1/3. Less than 0 because you divided by negative. Inequality sign changes from greater than to less than. From there you can find the critical values you indicate in your number line, and you find the values of the range of values of x that satisfy the inequality. You're going to get this. Now since you had another domain which was x different from 1/3, you now take the intersection between x different from 1/3 and this. Doing it, you're still going to get this interval. So the answer is B. So for those who have not understood, because I know maybe there's something you have not understood, you should not bother. In the next video I'm going to do, or before you write your GC for that math, we are going to have curve sketching uploaded, the video on curve sketching uploaded. So we are going to see how to find the domain of various functions. Alright, question 29 came from the topic logic, and it reads, which of the following is a statement? Option A, option B, option C, and option D. Now simply, a statement is simply a sentence that is true or false. So you just go to your options and you identify which statement is true or false. If there's any statement there that is true or false, then it is a statement. So automatically the answer is going to be A, because the sentence 7 is less than 3 is false. Therefore it is a statement. If it was true, it is also going to be a statement, because a statement is a sentence which is true or false. So option B says, what is the square root of 9? That is a question, so it is not a statement. And you can read the other options and deduce, so that the answer is A. Now question 30 is on hyperbolic functions. The question reads, the maximum value of 24 on 5 plus cosh x is. Now the maximum value of a function is simply a certain value that is always greater than that function, or that function is always less than that value. If I am always less than you, it means you're my maximum. That's practically. So in this case, to find the maximum of a rational function, we begin by finding the minimum of the denominator, and I'm going to explain why we begin by finding the minimum of the denominator after we have found the minimum. Now we need to find the minimum value of 5 plus cosh x. So we begin by finding the minimum value of cosh x. So for all values of x in the set of real numbers, cosh x is always greater than or equal to 1. So 1 is the minimum value, meaning that 1 is always less than the function. That's why the function is always greater than 1. You can do it by using the derivative. You differentiate cosh x will equal to 0, and then you find the value of x. Now you determine if that x coordinate is maximum or minimum. If that x coordinate is going to give you a maximum point or a minimum point by using the second derivative. Like I said, in the next video we are going to explain everything about curve sketching and you're going to be satisfied. So for all values of x in the set of real numbers, cosh x is always greater than 1. So adding 5 on both sides, you get 5 plus cosh x will be greater than 5 plus or equal to 5 plus 1, which is 6. Now we want to find the maximum of this. Like I said, we begin by finding the minimum of the denominator. So since we need this function, we need to take the reciprocal on both sides of this equation, and then we multiply by 24 to get this function. But if we take the reciprocal on both sides, the inequality sign is going to reverse due to this principle. The principle says that if I have two numbers that are positive, and let me just say a is less than b, then 1 over a will be greater than 1 over b. For example, 2 is less than 3, then 1 over 2 is greater than 1 over 3. That's what we are seeing. So 5 plus cosh x is greater than or equal to 6. It means 1 over 5 plus cosh x will be now less than or equal to 1 over 6. Multiplying both sides by 24, we get the function which is y to be less than or equal to 24 and 6. But 24 and 6 is 4. So it means the maximum value of this function, like we said, it is a certain value that the function is always less than that value, meaning that value is always greater than the function in return. So we have 24 divided by 6 is 4. So the maximum value of this function is equal to 4. So the correct answer is option D. Alright, so we are going to proceed with question 31. It came from the topic moment of inertia, but actually rotational dynamics, the subtopic moment of inertia, because that was what was concerned with the question. The question reads, the moment of inertia of a uniform solid sphere of mass 2m and radius a about a tangent line to the sphere is. So the objective is to find the moment of inertia of the uniform solid sphere about a certain tangent line. They have characterized the sphere by giving the mass of the sphere and the radius of the sphere. So this is what we are doing. We are finding the moment of inertia of this sphere about this axis which is tangent to the sphere. I can name the axis delta 1. But it is easy to find the moment of inertia of this sphere about an axis that is passing through the center of the sphere. I can call that axis delta 0. If you check your formula booklet, you're going to see the formula. It is 2 feet the mass of the sphere times the radius of the sphere squared. The mass of the sphere is 2m and the radius of the sphere is a. So with that we get 4ma squared divided by 5, which is the moment of inertia of this sphere about this axis delta 0, that is an axis passing through the center. Now the objective of the equation is to find the moment of inertia of this sphere about an axis that is tangent to the sphere, the axis delta 1. So we can relate these two axes by the term parallel. The axis delta 0 and the axis delta 1 are parallel. So with that we are going to use the parallel axis theorem. Now the parallel axis theorem is telling us that if we want to find the moment of inertia about a certain axis, and we know the moment of inertia about another axis that is parallel to that other axis that we want to find the moment of inertia about, then we just use the formula delta I0, which is the moment of inertia about the axis that we have found, plus the mass of the sphere times the square of the distance separating the two axes. So since we have found the moment of inertia about the axis delta 0, then to find the moment of inertia about delta 1, the axis delta 1, which is the axis tangent to the sphere, we just take the moment of inertia about delta 0 plus the mass of the sphere times the distance times the square of the distance that is separating the two axes. The distance separating the two axes is simply the radius of the sphere, which is A. So with that, since we have found this delta I delta 0 as 4ma squared divided by 5, we just add it with 2ma squared because 2m is the mass of the sphere. So with that, we get 14ma squared divided by 5. So the correct answer is D. Now question 32, we are rounding up, is on polar coordinates. The equation with the polar equation of the curve x squared plus y squared plus equal to 4y is, we have the various options. So we are trying to change from the Cartesian plane to the polar plane. So in the polar plane, the x coordinate is r cos theta and the y coordinate is r sin theta of any point. So from there, we can get x squared plus y squared to be r squared. So imputing x squared plus y squared as r squared in this equation and imputing y as r sin theta, we get r squared, which is x squared plus y squared, equal to 4y, but y is r sin theta. So we can divide both sides by r and we get r to be equal to 4 sin theta. So the correct answer is A. Now question 33, it came in the topic partial fractions. Came from the topic partial fractions. That's the question, and the objective is to find the value of the constant here. So this is what we are going to do. We can do the usual, look for the LCM. Now we take x plus 2 all squared times x squared plus x plus 1, and we divide with x plus 2 and we multiply with p to get this first component. So doing that, we get p into x plus 2 times x squared plus x plus 1. We do the same thing to q and we do the same thing to rx plus s. From there, we now equate the numerators of the both ratios. Since their denominators are the same, the denominator is the same as the denominator, so we equate the numerator. So 9 plus 3x will be equal to p into x plus 2 times x squared plus x plus 1 plus q into that quantity plus rx plus s into the other quantity. Now the main aim is to find the value of the constant q. It means we need to eliminate this quantity here and this quantity here, and to eliminate that, we simply set x to be negative 2. Setting x to be negative 2, the left hand side becomes 9 plus 3 times negative 2, which is 9 minus 6, which is 3, and the right hand side, fitting x to be negative 2 here, this term disappears and this term disappears. Now negative 2 all squared is 4, minus 2 is 2 plus 1 is 3, that's why we have 4 times 3. From there we divide both sides by 3 and we get our q to be 1. So the correct answer is B. And the last question came from topic complex numbers, and the question reads, given that z cube is equal to 2 plus 2i, the modulus of z is, so our z cube is given by this. Now the modulus of a complex number is just the square root of the sum of the squares of the real and the imaginary parts. The real part is 2 and the imaginary part is 2. So the modulus of my complex number z cube is the square root of 2 squared plus 2 squared. Now 2 squared plus 2 squared is 8, which is the same as 2 cubed. So the modulus of my complex number z cube is equal to 2 cubed. But the objective is to find the modulus of the complex number z. So since the modulus of the complex number z cube is this, to find the modulus of the complex number z, we just take the cube root on both sides, that is raising both sides to the power 1/3. So raising the left hand side to the 1/3, we just get the modulus of z by the properties of modulus, and raising the right hand side, we get this. Now from there, this 3 here can cancel with the 1/3 and we get the modulus of z to be equal to 2. So the correct answer is A.